In this video we're going to make further use of exponential and logarithm functions. So in order to do this we need to remember both the rules of indices and also our four basic rules of logarithms that were established in the last video. So our first example then is we've got to solve the equation e to the 2x minus 16e to the x plus 63 equals 0. Now a really important key step right at the beginning of this is to realise that e to the 2x can also be written as e to the x squared. That's using one of our rules of indices. So making use of that, we can rewrite the equation as e to the x all squared minus 16 lots of e to the x plus 63 equals 0. And if I write y equals e to the x, what I've got clearly is a quadratic equation, y squared minus 16y plus 63 equals 0, which factorises, or of course I could use my calculator to obtain the solutions of y equals 7 or y equals 9. So that now tells me that the value of e to the x is either 7 or 9. Taking natural logarithms of each side tells me that I've got x is either the natural logarithm of 7 or the natural logarithm of 9. Or to 3 decimal places, I've got x is 1.946 or 2.197. Moving on to a second example, we've got to solve the equation 3 to the 2x plus 1 minus 12 times 3x minus 57 equals 0, giving our answers correct to 3 decimal places. Now, in this case, the critical thing to do to begin with is to consider this term, which is 3 to the 2x plus 1, and to use the rules of indices to try and find a slightly different way of writing that. We can say that 3 to the 2x plus 1 is the same thing as 3 to the 2x times by 3 to the 1. 3 to the 2x is the same thing as 3 to the x all squared. Still times by 3 to the 1, which is 3. In other words, we've got 3 to the 2x plus 1 is the same thing as 3 lots of 3 to the x squared. So my equation can be written as 3 times 3 to the x squared minus 12 times 3 to the x minus 57 equals 0. And this, you may well be able to spot, is a quadratic equation in 3 to the x. If you don't spot that straight away, the thing to do is to make a little substitution as before. Let's say y equals 3 to the x, in which case our equation that we've got becomes 3y squared minus 12y minus 57 equals 0. Solving that quadratic equation gives me, from the calculator, y is either 2 plus root 23 or 2 minus root 23, which tells me now that 3 to the x has to be either 2 plus root 23 or 2 minus root 23. Now 2 minus root 23 is a negative number, whereas we know that 3 to the x is always a positive number. So we can delete that possibility. So we've got the solution of the equation is given by 3 to the x must equal 2 plus root 23. And I can then deduce that x must equal log to base 3 of 2 plus root 23, which is approximately 1.744. If your calculator doesn't have a log to any base on it, then we've got a way of solving 3 to the x equals 2 plus root 23 by simply taking logs to base 10 on each side. If you can't remember that, go back and look at the previous video. For our next example, we've got two inequalities to solve. So let's have a look at the first example, first part. We've got 1.2 to the power x is smaller than 5. Now what we want to do is take the logarithm of each side. And one of the important things about the logarithm function is that if a is smaller than b, then the logarithm of a will be smaller than the logarithm of b. Remember, as always, if I'm writing log, that means log to base 10. So I'm going to take the logarithm of each side of the equation, and that will give me the logarithm of 1.2 to the power x is smaller than the logarithm of 5. But one of my basic rules of logarithms said that the logarithm of 1.2 to the power x is going to be the same thing as x times by the logarithm of 1.2. So I've got x times by the logarithm of 1.2 must be smaller than the logarithm of 5. If a and b are two numbers with a smaller than b and k is a positive number, then I know that a divided by k is smaller than b divided by k. Now the logarithm of 1.2 is the logarithm to base 10 of 1.2 is 0.079. And that is definitely a positive number. So I can safely divide each side of the inequality by the logarithm of 1.2 to obtain x must be smaller than the logarithm of 5 divided by the logarithm of 1.2. And just using my calculator now, I've got x is smaller than 8.827. For part B, I can start in very much the same way. I've got 0.4 to the power y is smaller than 0.0001 is the inequality to be solved. So taking logarithms of both sides, I've got the logarithm of 0.4 to the y must be smaller than the logarithm of 0.0001. Logarithm of 0.4 to the power y is the same thing as y times the logarithm of 0.4. So I've now got the y times the logarithm of 0.4 is smaller than the logarithm of 0.0001. Now unfortunately the logarithm of 0.4 is a negative number. It's minus 0.3979. And what I need to be really careful of at this stage is to remember that if a is smaller than b, and m is a negative number, then a divided by m is going to be bigger than b divided by m. In other words, if I divide through by a negative number, then the inequality reverses direction. So dividing through by log of 0.4, which is a negative number, is going to give me y is bigger than the logarithm of 0.0001 divided by logarithm of 0.4. In other words, y is bigger than 10.05. For example 4, we're going to try and solve the equation log to base 4 of 10x plus 6 minus 2 log to base 4 of x is equal to 1. To solve this equation, we really do need to know our 4 basic rules of logarithms and be able to use them efficiently. 2 log to base 4 of x is the same thing as log to base 4 of x squared. That's rule number 4. Okay, so I can rewrite the equation as log to base 4 of 10x plus 6 minus log to base 4 of x squared equals 1. That was using rule 4. Using rule 3, I can say that log to base 4 of 10x plus 6 minus log to base 4 of x squared is the same thing as log to base 4 of 10x plus 6 divided by x squared. So we've got, using rule 3, log to base 4 of 10x plus 6 over x squared must equal 1. Using my basic definition of logarithms, the fact that log to base 4 of 10x plus 6 over x squared is equal to 1 means that I can say that 10x plus 6 over x squared is 4 to the power 1. which is 4. So that was using rule 1. So I've now got 10x plus 6 equals 4x squared, or 0 is 4x squared minus 10x minus 6. Solving the quadratic equation gives me x equals 3, or x equals minus 0.5. Now, if I have x equals minus 0.5, then the logarithm to base 4 of minus 0.5 does not exist. I can't take the logarithm of a negative number. So x equals minus 0.5 does not satisfy the original equation. So we need to delete that solution. So with x equals 3 on the other hand, log to base 4 of 10x plus 6 minus 2 log to base 4 of x is log to base 4 of 36 minus 2 log to base 4 of 3. Using our calculator or using the properties of logarithms, we can show that that is equal to 1. So the solution to our equation is x equals 3. Now for our final example, we're going to be looking at the graph of y equals e to the 2x minus 8e to the x plus 12. The point A is where the graph crosses the y-axis, B and C are where the graph crosses the x-axis, and D is the minimum point on the curve. And the line L is the line that the graph approaches as x tends to minus infinity. And that's called the horizontal asymptote of the curve. So first of all, we've got to write down the coordinates of the point A, where the curve crosses the y-axis. That's nice and straightforward because the point A is where the x-coordinate is 0, so we can say that y is e to the 0 minus 8e to the 0 plus 12, and provided we remember that e to the 0 is equal to 1, that gives me y must equal 5. So A is the point 0, 5. Now, as x tends to minus infinity, the curve is getting closer and closer to the line L. Now, as x tends to minus infinity, we know that e to the x is going to tend to 0, and e to the 2x is going to tend to 0. So, the value of y is going to get closer and closer to 0 minus 0 plus 12. In other words, the value of y is going to get closer and closer to 12. So the line L has got equation y equals 12. We've now got to find the exact coordinates of the points B and C where the curve crosses the x-axis. Well, the curve crosses the x-axis where the y-coordinate is equal to 0. So we've got to solve the equation e to the 2x minus 8e to the x plus 12 equals 0. This is very similar to the equations that we were looking at earlier on in this video. We need to remember that e to the 2x can be written as e to the x all squared. So the equation is equivalent to e to the x squared minus 8e to the x plus 12 equals 0. Now this is a quadratic equation with e to the x as the unknown. So if we make the substitution p equals e to the x, we've got p squared minus 8p plus 12 equals 0, which tells me that p is either 2 or 6. So that tells me that I've got e to the x is 2 or e to the x is 6. In other words, x is either the natural logarithm of 2 or the natural logarithm of 6. In this case, we're being asked for exact solutions, so we shouldn't work these values out. We should leave them just as their exact values. Logarithm of 2, logarithm of 6. B is the point logarithm of 2, 0, and C is the point natural logarithm of 6, 0. For part D, we want to find the minimum point, and the minimum point is going to be where dy by dx equals 0, we know that y is e to the 2x minus 8e to the x plus 12. We know the gradient of e to the 2x is 2e to the 2x. We know the gradient of e to the x is e to the x. So the gradient rule we've got is dy by dx is 2e to the 2x, take away 8e to the x. At the point D, we've got 2e to the 2x minus 8e to the x equals 0. E to the 2x, as before, we can regard as being e to the x squared. So I've got 2e to the x squared, take away 8e to the x equals 0. Again, we've got a quadratic equation in e to the x. Even easier in this case is we can factorize this because we've got a common factor here of 2e to the x. So I've got 2e to the x times e to the x minus 4 equals 0, which tells me either e to the x is equal to 0 or e to the x is equal to 4. E to the x is always a positive number, so can't be 0. So the only solution I've actually got is e to the x equals 4. And if e to the x equals 4, then I have got x is the natural logarithm of 4. So I now know that the x-coordinate of the point D is the natural logarithm of 4. We already know that at the point D, the value of e to the x is 4. I've got y is e to the x squared minus 8e to the x plus 12, but I know that e to the x is 4. So that is 4 squared minus 8 times 4 plus 12, which gives me minus 4. So the point D has an x-coordinate of the logarithm of 4 and a y-coordinate of minus 4. So that concludes our video looking at further uses of the exponential and logarithm functions.